Have you ever wondered how a sprinkle of sugar transforms into a gorgeous golden caramel? This everyday magic isn't just a treat for the taste buds, but a fascinating dance of chemistry. Caramelization begins when sugar, which is a carbohydrate, heats up. As the temperature rises, sugar undergoes a series of complex chemical reactions. It's not just about melting sugar, it's a thermal decomposition process. When sugar reaches a temperature of about 340 degrees Fahrenheit, it starts breaking down. This breakdown isn't a simple affair. Each molecule of sugar, primarily sucrose, splits into glucose and fructose, two simpler sugars. As the heat continues to work its magic, these sugars undergo further transformation. They release water and react with each other, forming new compounds. This is where the flavors and colors start to develop. These new compounds include a variety of aromatics, acids, and other types of molecules that contribute to the rich brown color and the deep, complex flavor profile of caramel. One might think it's just browning, but it's not to be confused with the Maillard reaction, which involves amino acids and requires proteins. Caramelization is purely the alteration of sugar by heat. The process is highly sensitive to the temperature and the type of sugar used. Different temperatures and different sugars can lead to a variety of flavors and colors. For instance, fructose caramelizes at lower temperatures than glucose. This sensitivity is why controlling the heat is crucial in achieving the perfect caramelization. Too high and the sugar burns, producing a bitter flavor. Too low and the transformation is incomplete, lacking that characteristic caramel charm. In culinary arts, caramelization is not just about creating a delightful topping for crème brûlée or a swirl in your morning latte. It's about unlocking flavors and colors that enhance the sensory experience of food. Chefs around the world harness this reaction to add depth to everything from desserts to savory dishes. In summary, caramelization is a chemical ballet where sugar transforms under heat, breaking down and reforming into new flavorful compounds. This process is pivotal in cooking, turning simple sugars into complex flavors and colors that elevate our culinary experiences. So the next time you savor a piece of caramel, remember, it's not just cooked sugar. It's a marvel of chemistry at work.